2.5 is postulates and paragraph proofs. So like I told you the other day, we only ever do a 2-column proof, but a paragraph proof isn't really, it's not that different. It's the same concept as a 2-column proof, except for you actually write it out in a paragraph form. So it's really not that big a deal, but we don't do those. So with today, it's going to be a bunch of maybe like theorems, definitions, postulates, where yesterday when we did algebraic proofs, you already knew all those. You knew like addition, property of equality, and reflexive and symmetric and stuff like that. So these are geometric. So these are ones that you maybe didn't know had like a rule or a reason to them, but they do. Okay? So a postulate is a statement that is accepted as true without proof. I feel like we've actually kind of talked about that before, but we didn't really use them yet. So these are in your book. I just kind of took the picture from your book. Obviously, you have the words, but you don't have a picture. So if you wanted that, you're welcome to draw it on your own, but I think probably for most of them, they're pretty self-explanatory. So the first one is postulate 2.1. Again, you guys don't want to memorize that. You don't want to tell me it's 2.1 because even I don't know what 2.1 is. That's not really helpful to me. And in another book, that could be like 3.7. So you want to know the words instead. Through any 2 points, there's exactly one line. You guys have known that for forever. How many points do you have to make a line? 2, right? Same thing, okay? So here's a picture, 2 points, line, all right? Through any 3 non-collinear points, there's exactly one plane. So again, we've talked about this in another chapter, but in a little bit of a different way. So you see ABC is 3 non-collinear points. You see capital cursive letter K, that means it's a plane. So there's your picture. Okay, and then it goes backwards as well, like we've done before. A line contains at least 2 points. So this one has 3 points, which is fine because at least means 2 or more, right? A plane contains at least 3 non-collinear points. So here they're showing you 4 because you can have more than that, right? If 2 points lie in a plane, then the entire line containing those points lies in that plane. So for example, line M has points A and B on it. So if A and B are in plane K, then the whole line of M is in plane K. Okay? And remember that planes and lines extend forever indefinitely in all directions for the plane, and then the line obviously goes both directions forever, but in the picture I obviously can't draw it forever big. So even though the plane looks like it's a parallelogram and it looks like it stops here, it really doesn't. Okay? 2.6. If 2 lines intersect, where do 2 lines intersect at? We've talked about this. A point, right? And where did 2 planes intersect? A line, okay? So 2 lines intersect in a point, and 2 planes intersect in a line. I don't think I told you anything today that we haven't covered. It's just been a long time ago. All right? A proof is a logical argument where each statement is supported by a statement accepted as true, which is what we did yesterday, right? So we had our statements on the left, and then we had a reason we were allowed to say it on the right, okay? A theorem is a proven statement or conjecture. So for example, the other day I told you guys the Pythagorean theorem, right? So that's something that we use all the time because it's already been proven. I don't have to prove it again. I can just use it over and over again, okay? So the first one we're going to talk about is the midpoint theorem. If M is the midpoint of line segment AB, then AM is congruent to MB. So I'm going to draw that, okay? If M is the midpoint of AB, then AM is congruent to MB. Again, we've done that before, but we didn't really pay attention to like what it was called or what we had to name it. Does everybody remember doing midpoints? It was smack dab in the middle. It cut it into 2 congruent pieces, right? Anybody still need that page? Okay. All right, explain how the figure illustrates that each statement is true. Then state the postulate used. So planes P and Q intersect in line R. So plane P and plane Q. It looks like plane P is on the left and plane Q is in front, and then line R is right here. Do you guys at least see that? Okay, so which postulate says that? And it's kind of hard because sometimes 2 postulates look the same, but you have to really at least narrow it down to 2 and then be like, which one says this exactly? Which one talks about 2 planes intersecting in a line, basically? 2.7. So again, even though I told you not to memorize that, it's right above us, and we don't want to write a sentence if we don't have to. So I'm okay for today on the notes if you just write postulate 2.7. That'd be fine. On your homework, I would probably do both. I would write postulate 2.7, and then I would say the sentence behind it. Okay? All right, lines R and N intersect at point D, right? Here's R, here's N, intersecting at a point. Which postulate says that the best? 2.6. Do you guys get that? It's pretty easy, right? Just pick one. Okay. Number 3, line N, right here, contains points C, D, and E. Which postulate says that? 2.3, very good. 2.3, which says a line contains at least 2 points, because they said 3, so that would be at least 2 points. Does that make sense to you guys? So some of these might seem like they're related, and they are, but there's always one best right answer. Okay? Line N is in plane Q. N is in plane Q. Which one do you think that would be? Yep, 2.5, which says if 2 points lie in a plane, then the entire line containing those points lies in that plane. Does everybody get that? You're just picking one. It's not terrible, right? Okay. Anybody still need that page? All right. Determine whether each statement is always, sometimes, or never true. Explain your favorite. Okay, you ready? 25. There are at least 3 lines through points J and K. This is a random question. There's no picture. Okay, so you might want to draw your own if you can, if you find it helpful. But it's not like the picture from the front. Okay, so one more time. There are at least 3 lines through points J and K. What do you guys think? Always, sometimes, or never? You're right. You have to have at least 2 points, right? Two lines or 2 points? What do you say? Yeah, you have to have at least 2 points. I'm going to go ahead and tell you it's never. Sometimes was close. At least you didn't say always, right? Sometimes it's close, and we'll talk about it. So I said never, and it goes against one of our postulates. Go back to the front and see which postulate this negates. Through only 2 points, there's exactly how many lines? 1 line, right? So it goes against 2.1. Through any 2 points, that's what this is, right? There's exactly 1 line. So they literally negated a postulate, so that's never, right? Always would be if it says a postulate or theorem. Sometimes as if it's like in between, and never is like literally they said something wrong, right? All right, points X and Y are in plane Z. Any point collinear with X and Y is in plane Z. I'm going to draw a picture this time. Okay, so here's plane Z. They said X and Y are in it somewhere, right? Any point collinear with X and Y, like this, is in plane Z. What do you think? Always. If X and Y are in plane Z, and then whatever point we just added is on X and Y line, then it's on the same line. It's still in the same plane, right? So what postulate says that? A line. So if we go back to which postulate says that? Hold on. Where is it? There's one that says. I think so. Yeah, that's the one I'm going to write down. But yeah. Yeah, exactly. If 2 points lie in a plane, then the entire line containing those points lies in that plane. So that answers your question. And I think that's the one that I was going to write down anyway. Yeah, 2.5. Do you guys get that? If the line is already in the plane, which they just said that, then if I put any point on that line that was in that plane, it's still in that plane, right? It didn't like jump outside of the plane. Okay? Points A, B, and C determine a plane. What kind of points determine a plane? Let's be very specific. What kind make a plane? Non-collinear. Did they say what kind these were? So sometimes, right? We don't know. We don't know if they said collinear or non-collinear. They didn't specify. So this would be a sometimes. Very good. Which postulate would help us with that? Well, I guess let's not say that. I just said they could be collinear. That would be fine. Thank you. Did I lose anybody anywhere? I know always, sometimes, or nevers are challenging for you guys, but again, if it says a theorem, it's going to be always. If it goes against a theorem or a postulate or a conjecture, it's going to be never. If it's an in-between, like this last question was, it's a sometimes. Depends. They weren't specific enough, right? Any questions? Okay.